Hello, everyone. Welcome to our talk and XOXO for Declarative UI. We all know Declarative UI has been pretty popular recently with Android using Compose, iOS using Swift UI. And we also know web has been using Declarative UI for quite some time using React. That's why we wanted to do a quick comparison to see the similarities between the three declarative frameworks using a tic-tac-toe board game. Before we go ahead and start looking into how we created the framework, let's introduce ourselves. My name is Sweety Bertilla. I work as a senior Android engineer for Comcast Cable and also a tech lead for my feature team. My feature team involves working on cool IoT devices using MQTT. With that, Dheeru, would you like to introduce yourself?
Sure. Thank you, Sweety. Hello, everybody. My name is Dheeru, and I am an iOS developer, and I mostly work on the IoT stuff right now. And I work with Sweety in the same Comcast, and I am interested in learning new technologies and also break the functionality and then set it up again. With that, Justin, do you want to introduce yourself?
Yeah, thanks, Dheeru. My name is Justin Thomas. I'm also a senior engineer at Comcast, and I'm the web platform lead, currently working on the Xfinity X5 project, which is an application for Xfinity internet subscribers that allows them to manage their home Wi-Fi networks, the devices that are able to connect, the data that they've used, that sort of thing. And as you can probably guess by my profile photo here, I'm an avid skier, and I generally like getting lost in the woods whenever I'm not working at my computer. So thanks for listening to our intro. And I think at this point, Dheeru is going to take us through a quick introduction of some of the similarities and differences between declarative and imperative UIs.
All right. Thank you, Justin. So before we start talking about the project, let's take a little let's talk a little about more what a declarative and imperative UI is, and I'll also give you a simple example just so we understand what it is exactly. So the imperative programming is one of the most commonly used patterns where the state is actually tied to the UI. But one thing that we have to keep in mind is the state management is not really easy. And the imperative programming describes how to implement the UI. Now, coming to the declarative programming, it is basically stateless. And one of the other things here is the state management is mostly decoupled from the user interface. And the declarative programming describes what to implement for the user interface. Now that we talked about the definitions, let's talk a little more about a simple example that we see normally in our day-to-day life. Declarative programming is like basically asking your friend to draw an image, and you don't exactly care how they draw it. It's just totally up to them. Now, the imperative programming is like your friend listening to some X person tell them how to, maybe example, how to paint a landscape, while that X person isn't exactly commanding, but they're just giving them a step-by-step direction to get the desired output. So that's basically what an imperative programming is. So now that we know what declarative and imperative programming is, let's talk more about a tic-tac-toe application that we have right now in 3 platforms. And Sweety, do you want to go ahead and talk about those all things?
Sure, Dheeru. Thanks for giving a great example of the difference between the declarative and imperative. Let's look at how we built a simple tic-tac-toe board in Compose, Swift UI, and React. I'm going to show a small demo on the tic-tac-toe board in Compose. Let me play this. So before I play, just look at this. I have a title which says tic-tac-toe in Compose, and you do see Compose is in italics and it's underlined. And then I have the board itself, which is in circles, and I have a restart button to clear the board. Let's look at this. Here I'm pressing the X mark and the computer is giving me the O. And then I'm pressing it and the computer is giving me O. And it says a computer 1. I made it 1 because it lost 99 times. So I just wanted to win for 1 time. And then when I clicked on the restart button, it cleared the contents in the screen. Let's look at how it's been done in Swift UI with Dheeru explaining it.
All right, so we almost have the same thing as what Compose has. We have a title at the top, and we have a grid, which we will be talking about in the next And we also have a restart button, which basically restarts the complete application so the user can start from the scratch again. So we have a view which has some title, some X and O's where you get the notification when the user taps on them and we play accordingly. Now, when the game gets finished, we show an alert and then we show some titles and we show who has won the game. So it's almost same as what Compose has. I'll let Justin talk about what they did in React.
Thanks, Dheeru. So as you can see here, things are starting to look pretty familiar. We've got our title for the game, tic-tac-toe in React, the grid or the game board. So our 3x3 grid that houses each player's moves, and a restart button at the bottom of the screen, as well as an alert or a modal or a pop-up that shows up that tells us who won the game. Similar to Sweety, I promise I am better at tic-tac-toe than this little demo might suggest, but for the purposes of the demo, we let the computer win here. So now that you've seen the similarities between what this game looks like in 3 different platforms, 3 different languages, 3 different frameworks, let's take a look at some of the similarities we can share with the actual source code of these applications. So first, we'll take a look at how we handle the overall application alignment. So the overall view of the application itself in Compose. So one thing to know about Compose and kind of where it gets its name is that Jetpack Compose allows us to build UIs with composable functions, hence the name Compose. And those UI elements are hierarchical in that the elements can contain other elements and be used to control their positioning and layout. So for our overall layout of our game, we've got a column. So this column function takes some modifiers in the horizontal alignment, vertical alignment modifiers that allow us to center horizontally. And for our vertical arrangement, we're using the space around modifier to give us a nice even top to bottom layout for our application that takes up the whole screen. Inside our column element, we've got a row, a lazy vertical grid, an alert dialog, and a button. And these are all, again, composable functions that we can pass into our parent function here being column, stating that these are all going to be children of that column, and the column dictates how they're laid out within the application. So let's take a look at what this piece looks like in Swift UI. This probably looks a little familiar. Kind of similar to what we're doing in Compose. However, one major difference we have here is the geometry reader, which in Swift UI just gives us the real estate that we have available for us to work with on screen. So it's giving us the height and width of the screen. Inside that height and width that we have at our disposal, we're using a VStack, which functionally is going to be very similar to Compose's column. It's going to give us our vertical orientation to our app. And then inside of our VStack, again, we're passing more functions into that. We've got an HStack, which will give us our horizontal layout for our title, a spacer, a lazy vgrid, which is going to be very similar in functionality to Compose's lazy vertical grid, followed by a button and a modifier for our alert that will let us know who won the game. And an interesting thing that I found about stacks is that they center their content by default and provide context appropriate padding, which is kind of handy. So taking a look at what we did in React, things may look a little bit different here. Like we're looking at essentially plain old JavaScript and HTML, but functionally, this is working the same as what we see in Compose and Swift UI. These custom elements that we've created in React essentially map back to composable functions that we've written in JavaScript. So we've got our game container that's going to house the entirety of our game. And then inside that, we're passing a title as a parameter to that game container. So the game container itself can act upon that. And then as children, we've got a game grid, which is again our 3x3 grid that houses our buttons, a restart button, and our game status, which is going to trigger the alert that we saw in our demo. To handle the actual layout of this, we can rely on CSS's flexbox, and we're using a flex direction of column to give us the vertical orientation to our layout. Moving along from the major hierarchy of the application, let's take a look at what we're doing for our title. The title is a lot simpler than what we've got going on for our main application layout. As we saw earlier, we're using a row inside of Compose to give us our horizontal orientation to our text. Inside that, we have two text elements, the first containing the tic-tac-toe in text, the second containing Compose, our language or framework of choice here. Each of those text elements then gets modifiers for font weight, font size, color, etc., to handle the styling of them. When we look at Swift UI, things look very similar. Instead of a row, we're using an H stack, but functionally everything's pretty much the same here. We have two text elements. They're both getting modifiers to control the size, font weight, italics, underline, that sort of thing. Syntactically slightly different, but functionally essentially the same. Now taking a look at React, you might be thinking, if you're an HTML or web developer, there's not too much going on here. We don't actually need to do anything React specific here. We don't need to build our own functional component to handle anything that we want to do with our title text. That's because HTML and CSS inherently are declarative. Web developers know that using the H1 tag around our text, we're automatically going to get a heavier weighted font, a slightly larger font size, and that's based on the W3C standards that all web developers are familiar with, and they know when you use this tag, you're going to expect the browser to work in a certain way. To style the word React, our framework of choice here, we do wrap it in a span tag so we can more easily target that with CSS to specify our text decoration and font style. So now that we've taken a look at the first few pieces of our application here, Sweety is going to talk us through what we're doing for the game board itself.
Thank you, Justin. To start with, let's look at how we design the board, that is the grid board itself. So we are using a lazy vertical grid in Compose. And to let you know that lazy vertical grid is in experimental phase. So we may need to use the annotation at experimental foundation API, any method that's calling this lazy vertical grid. Now we have to set the grid cells. So there are the two ways of setting them. One is adaptive and one is fixed. So what's adaptive? So you can set your column width and you can say how many ever columns can fill that width of the screen. So if I say cell grid cells dot adaptive 30 dp, so it's going to set my column, each column 30 dp and fill as much as it can in a row. But I here need only 3 by 3. So I'm going to set fixed and pass the value 3. And the other things I'm doing is just setting the content padding. So this means the board will have some spacing around it with using start, top, and bottom. And also, you know that I mentioned that lazy vertical grid in experimental phase. So if you want to achieve the same result in something else, you could use lazy column and row. With that, let's look at how it's done in Swift UI. It's pretty much the same. Dheeru here has used lazy vgrid, but lazy vgrid is already in GA, so he doesn't have to use any annotation for this. And here he's passing columns, which is coming from the view model, which is handling the business logic. And he's passing probably 3 because again, we need the board to have 3 by 3. And he's setting some spacing that is 15. Let's look at the content. Inside the content, we are having a circle view, which is having a property called geometry reader. So what's this geometry reader? Probably we might have already known this, that geometry reader is just calculating the screen size. That's the height and width of the whole screen and spacing the circle view based on the screen size. Then he's using a system image to place the X or O on top of the circle view. And that's why he's using Z stack, because you cannot just use a circle view and place a player. It won't work. It'll throw a compile error. You can assume this as a frame layout, where in Android, if you're an Android engineer, where you want to place one at the top of the other. And then he's handling the tap gesture with the business logic. So when you click on this, any of the circle image, it will process in the view model, and it will show you whether to show X or whether to show O. With that, let's look at how it's done in React. It's pretty much the same. We also have a grid here, and you can look in the CSS at the bottom. You can see the game grid. It's saying the display as grid. So that implies that I'm going to use a grid for this. And also we are setting the columns. Again, we wanted the column to be 3 by 3, and that's why Justin here is setting as 3 with equal width. And then you can look at the top. So we are consuming this game grid in JavaScript, and we are passing circles and on click on that circle. And in the right, you could see the game grid component itself, which is basically using a map instead of a for loop. It's because map is an immutable declarative way to work with arrays instead of a for loops. And he's setting every circle on click what you need to do. With that, let's look at the board contents itself. I'm going to talk about in Compose first. As we already a little bit peeked into how it's been done in Swift UI. So we did see a circle view was used, and then a system image was used. Here, I'm going to use a box. Box is nothing but it's going to define the shape of the circle. I needed a circle. So that's why you could see inside the box, there is a property called clip, where I'm passing the shape, and the shape is a circle shape. Also, I'm setting certain other properties like size of the circle itself. I'm giving some padding around it. And I also am setting the background color as green. You didn't notice we had greens in our background color or foreground color for iOS. And clickable, it's been handled the business logic in the view model. So every time the user clicks on the box, we want to do some business logic. And then you see a text. Text is the child of the box. So I need to place the child inside the box. So I'm giving it inside the box. And I'm saying, I'm setting some text values, font weight, font size, color, where I want to align it, and some padding. Let's look at how you're doing the same in Swift UI. By now, you pretty much know that it's going to be more or less the same. Let's look at the top left. So we have a circle view. So how the circle view is constructed. So we are using a circle. So if you had compared in Android, we were using a box. Instead of that, in iOS, you just can directly use a circle. And you, instead of setting as background color, you can set it as foreground color as green. And you can set the frame, which is nothing but the width and height of the circle itself. Then in the bottom, then you could see that we are setting the values of the X and O. So in Android, we did see that we're using a text for showing the X and O. Dheeru could do the same, but he wanted to play a little bit different, and he wanted to take leverage of the system images that's been provided by Apple. So he's using an X mark to show the X mark icon, or a circle based on it's a human or a computer. And I think like Apple provides like 2,000 icons for free to use, right, Dheeru? Can you confirm that it's around
Yes.
like a lot of images?
Right, that is about 2,000 plus icons for free.
Wow, that's amazing. And if you look at the right top, you could see how we are setting that image. So we are calling something called image and passing the system image. We are saying it's resizable, and we are setting the width and height of it, and we are setting the color for this icon. So that means Dheeru can even set the color to something else. The X and O can be green, blue, or something else as well. Let's look at how it's done in React. Pretty much the same. There was a box, there was a circle, here's a button. I think in Android, I could do this as a button as well, but I really wanted to use box, which would be the common way to do that. Here, Justin has been using button, and he's naming the class name as circle. And you could see in CSS on the rightmost, what are the properties you needed for that circle? Again, we need green color. So he's setting the background color is green. He's setting a border radius style, the sizing, the font style, the weight, the line height, and pretty much all the properties that is needed for it. And then we go to the left, you could see the value. Value is where he's handling the text to show the X or the O. The circle component could have its own default click handler, but we are passing one in. With that, I'm going to give it to Dheeru to talk about the tic-tac-toe result.
All right, cool. Thank you, Sweety. All right, so let's talk about the result, which is an alert that we show to the user when the game gets finished, actually. So in Compose, we have something called, we have used something called alert dialog to basically achieve this. So it has a title called the game over, which we have used, where we've used text as a UI element. And our alert message comes from the view model, which basically decides what text needs to be shown based on the business logic. And we also have a confirm button, which is also called as an OK button. And we have used a button for the UI element to show this. So that's how we have done it in Compose. And coming to Swift UI, we have almost similar to what Compose has done, but we have used something called alert modifier to actually show the alert. And here we get the data from the view model, and that contains the title and the subtitle, and it completely depends on the business logic. And I mean to say who won the game, and based on that, we get the title and then the subtitle. And also, we don't have to do anything on the tap of the dismiss button, but again, if you wanted to add any custom functionality, you can still do so. That's how we have designed in Swift UI. And right now, coming to the React, React is a slightly different. So basically, the browser will not allow us to modify the default alert behavior. So we have to develop our own UI if we have to make it in declarative. And the alert method that you see calls the browser's default alert or modal, and it basically inserts the given text into it. So we don't basically have any control over the position, styling, or maybe functionality or anything within the default alert. Again, to be able to do any of those kinds of stuff, we need to create our own alert component. So that's how we work with the alerts on the tic-tac-toe app. Now, we will also go and talk about the restart button. And for showing the restart button, we have used button as our UI element in our and to show the text, we have used a text as a UI element, which is right inside the button. So when we tap on the button, we give the complete control over to the view model, and it handles again the core business logic. And with Swift UI, we have done almost similar to what we did in Compose. And it's just that we have used an extra modifier called overlay in order to get the rectangle shape around the restart button. You can do this actually in multiple ways, maybe by using a Z stack and having a rectangle on top of it, and then you can still use a text again to show it. But then, I thought it's overlay is something that we can use, which is pretty simple and easy to understand. So that's how we did it in Swift UI. And with respect to the React, we basically implement the React a restart button by passing its reference to the set circles, and set is next on the screen on the slide that you see right now. And these methods both make changes to our application state and are used by our on start click handler inside the actual restart button component. And with respect to the styling, it's totally being handled by CSS. So that's how we have designed, and that's how we have used. So I know it's a lot of information, but with that, Justin, do you want to summarize what we have done so far?
Yeah, absolutely. So if you, like this dog, are feeling maybe a little bit confused, we just went over a whole lot of information, especially if you're new to any of these frameworks. So let's take some time to summarize what we just talked about. We'll go through this component by component for you. So when we're looking at our overall application, how we control the layout of the application itself, in Compose, we use a column to display things in a vertical orientation, which if we were working in an XML-based layout would be similar to using a linear layout with an orientation of vertical. In Swift UI, we're using a VStack to arrange the child views in a vertical line. And in React, our game container component uses CSS's flexbox to control child component order and alignment. Diving down into our title row here. In Compose, we're again using a row with two text elements aligned horizontally. In Swift UI, we have those same two text elements, this time horizontally aligned using an H stack. And in React, we don't need to use React at all. We can just rely on HTML and CSS to handle this for us because web development is great. Now, Dheeru, if you want to take a look into what we did for the game grid itself.
Sure. All right. So for building the grid view, there are multiple ways of doing it, and one of them is by using a lazy columns and rows. But in our example, we have used a lazy vertical grid in Compose. For iOS, we have used a lazy vgrid in order to achieve it, which is almost similar to what Compose has. And for React, it's a little different from what Compose and Swift UI has. If you see particularly, there's something called the repeat 3-1 FR, which is basically saying to lay out 3 columns of equal width. And all the elements inside the grid will sequentially be laid out left to the right in the column, in the column structure. And once at the 3rd column, the next element automatically wraps back to the beginning and it gets displayed on the 1st column. So it's a little different from Swift UI and Compose, but it's almost the same. So that's how we have the code component in all the platforms. Now, in the previous slide, we have talked about how we laid out the grid, but let's talk more about how we have shown the X and then the O. These are almost similar in all the platforms. So we have used a circle view in order to achieve the circle, and we have used a text in order to show the X and O for Compose and React. But for iOS, we have used a system image instead of a text. And like Sweety said again, we can still use a text to show the X and O, but then we just wanted to make use of the system image just to show you guys that there are multiple ways of doing it. With that, Sweety, do you want to talk about the other components that we have used in that?
Sure, definitely. So we know that we are going to show a pop-up dialog after we play the game to know who won, right? So here you could see in Compose, we are using an alert dialog. And for Android engineers, you already should know what an alert dialog is, where you have the control to set the text, you can set the body, and you can set the confirm button. The other cool part is you can style them as well. So I can change the font size of the title, the body, and the text. And I can style however I want it. The same applies for Swift UI, where we are using an alert modifier, and we can also style the title, the body, and the confirm button. With React, unfortunately, web browsers don't let us control the default alert boxes, as in you cannot set the title, you cannot set the confirm button. Luckily for us, the confirm button was okay, is the default for browser, so we kind of leverage for Android and iOS. But I think you can still set the body of the alert dialog. That's true, right, Justin?
Yeah, that's correct. We do have access to change the actual text of the dialogue there, but as you said, unfortunately, we can't change the title of it. We can't change the text of the button. We don't really have any control over its styling, placement, font styles, any of that sort of fun stuff. In a real world application scenario, we really wouldn't be using the alert functionality that's baked into the browser. We would be building our own declarative modal or alert pop-up kind of component for this.
Awesome, thank you. With that, let's look at the restart button. We did know what the restart button is supposed to do. So once your game is done, I want to clear the board so we can play it again. So here we are using, as the name I was using is button. So we are using button, and the child for this button is the text. Other cool feature, I can style the button however I wanted. Right now, the default button is showing as rectangle. I can change the shape, the color, and you can see here, I have used a red color for the button. And then there is a child text. That's where I'm presenting the restart string. So here, again, I can style the restart string by changing the color, where here I've used a white color. I can set the font style. I can set padding. I can set whatever I want with that. Pretty much the same in Swift UI. So there's again a button, there's again a text, and the only thing is you might have to use overlay to get the rectangle shape, because by default, it doesn't show you the background image. That's the only thing you have to do in iOS. And again, React, same. button, 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 wrapped in React component to give buttons click handler access to the app state. With all this, we would like to talk about the takeaways and benefits we got by doing this project itself. I could start first by saying when I was working on the project, one thing I could know is that there's no Android, there's no iOS, there's no React. Or no web. I felt like it's just one language, declarative UI. We could speak more or less the same language. I can even do code reviews in our feature team. Even though we work on the same feature, we always have separate channels for Android code reviews, iOS code reviews, and web code reviews, even separate guild channels to talk or discuss about Android, iOS, or web. With this, I have confidence I can go code review iOS or web in declarative UI. I can even go get a little bit dangerous and even go create a PR in Swift UI or in React. With that, Justin, would you like to add something? And Dheeru too?
Yeah, I think you bring up a couple of really good points here. The first thing for me that I noticed as being a huge benefit to working in a declarative UI paradigm is, as you said, the collaboration between platforms. And this is something that we do actually practice within Comcast. We have a team that's solely dedicated to building out what is essentially an organization-wide UI system or UI library. So that team is comprised of web developers, Android developers, iOS developers, even developers working on our set-top box. And using this kind of shared design language, naming conventions and things of that sort, they're able to build components that are going to work similarly across all these different platforms. And in turn, as Sweety said, review each other's code to make sure that they're staying on brand, make sure that they're being consistent in their styling and their functionality from one platform to the next. And the other thing that I've noticed on my team specifically, since we have been working with React for several years now, the application that I work on is very large. It touches a lot of different things within the Xfinity ecosystem. And at points, the team that I'm on has had upwards of 20 web developers working on this application at any one time. Trying to manage a code base that large with that many developers when you're working in an imperative paradigm gets messy really quickly. And working in this declarative paradigm has allowed us to not only scale the size of our application, but scale the size of our team very quickly and easily, and keep things pretty manageable, and create lots of reusable components that make that scaling easy. And I'm assuming you, Sweety, and Dheeru have seen similar benefits on your platforms as well.
Right. Yes, and +1 on both whatever you said, Justin and Sweety. I totally agree with all of those points. And honestly, I've learned a little, at least some good architecture and some of the UI components that you have been using in React, web, and also in Compose, which is in Android. And as we work mostly with the asynchronous code and with the declarative programming, whenever I get stuck, I'm right now, at least, I'm able to go ahead and then see what the data flow is just by looking at the UI element and then start debugging it from there. So I am able to get it right now way better than what we used to have, at least with compared to Android. We still have right now the XMLs, but with the declarative way, that helped me a lot. And it also gave me some good confidence that I can be a good engineer. I mean, I can start working on Combine and working on the Compose and Swift UI at the same time, and also learn React on the website. So it gives me some good confidence whenever I work on these kinds of stuff. So I see all the advantages, and I think we should be able to start working on them.
I totally agree, especially debugging. It's always a pain with imperative UI. And also, like, I could say that, hey, I used a box and this view didn't work, but then I can talk to you both and you can say, actually, button worked in this. Why don't you use a button? And I could definitely go and do that instead of saying, oh, Android, it's different. I cannot just use button. But now I cannot say that. I have to say, oh yeah, this it works in button for React and for Swift UI. Then definitely it's going to work for Android and Compose.
Sure.
With that, we really thank you for coming and attending our talk, and we are ready to take any questions or feedback you have for us.
All right. Thank you so much for listening to our talk and giving this opportunity.
Yeah, thank you. If you don't want to chime in right now, we'll also be monitoring our talks Slack channel for the rest of the day. Feel free to ask questions in there if you don't have the time right now to do so.
Yeah, definitely. We'll be there in the Slack to answer questions. And we also added the Slack channel where you can go and submit your questions. And thank you, Sarah. Yes, we also found it really fascinating to be able to easily compare and work on this project. That was pretty cool. I'll go ahead and unmute if anybody wants to talk as well, which I don't know how to do that. Oh,
I unmuted it, Sweety.
Thank you so much, Dheeru.
Yep, the floor is open if anybody's got questions and they want to unmute.
Looks like it's pretty clear, whatever we explained. I'm just joking.
We are at 2:38. We are still here. We can wait till 2:40. And then we'll take any questions you have in the Slack as well. Please give us feedback. We'll really appreciate that to know, did you like it? What was missing? What you learned from this?
I have a quick question I could think of. So since they're going in the same direction and they're also similar now with declarative programming, how far away do you think we are from writing once and have it work everywhere? Some sort of like transpilation or something?
So if you guys don't mind, I'll take that one. We can do that right now. There are multiple languages that we could do that right now. And as we saw earlier, there was a presentation on Flutter. Flutter can be compiled down to work on iOS, to work on Android, to work on the web. We could do that right now with React and React Native. So I don't think we're far from that at all. I think we can do that realistically right now. Once you start going down that route, there are obviously some trade-offs that you get versus working in a given platform's native languages. And those are decisions that you kind of need to weigh on a project by project basis. But if your goal is really just to write once and deploy everywhere, that's totally possible right now.
Right. Yes, Flutter, I do know that there are trade-offs. I was kind of curious of how far are we from the point where we don't have those trade-offs, like where it's almost fully native for both?
That is a much harder question to answer, I think. Yeah. And maybe one of our mobile devs here can speak a little more clearly on that, but I think you're probably as far away as you are from each platform having feature parity. Does that make sense?
Yeah. Because I know that Flutter doesn't allow like there's limitations to working with specific like native libraries, right? Yeah.
Yeah, but these both are native. Only thing is I cannot write in Swift UI and deploy it in Android.
Right.
I have to write it in Compose. So one thing we could have is a design. That, like I said, I could say like, hey, we are designing a button. Let's make sure we use a button. And why do you want to use a box, or why do you want a circle view? So what's the reason instead of using a button? That's something we all can come together and have a common design that helps each of us to easily debug, easily discuss.
Right. Cool. Thank you.
Thanks, Kristen.